Hi, my name is Manish Gupta, and in this video, I will talk about Imagen, which is a photorealistic text-to-image diffusion model with deep language understanding. So let's get started. First question, what is Imagen? Imagen is a text-to-image diffusion model. It is a model to create images given text prompts. The images produced with Imagen are highly photorealistic, as well as they have a deep level of language understanding. Here are some of those examples. So as you see, sprouts in the shape of text Imagen coming out of a fairy tale book. Such a nice imagination. And hey, here are the sprouts coming out in the shape of Imagen. Right? Photo of a Shiba Inu dog with a backpack riding a bike. Now, it's all up to your imagination, what kind of prompts you want to provide. Imagen creates images accordingly. The architecture of Imagen sort of comprises of these three parts: a frozen T5 XXL encoder, which maps the input text into a sequence of embeddings, and then a 64x64 image diffusion model, and then two super resolution diffusion models for generating high resolution images, 256x256 and 1024x1024 images. Okay, so let's look into the detailed architecture of Imagen and try to understand. Right. As we said, the first part is pre-trained text encoders. So they tried several text encoders, BERT, T5, and CLIP, and they found that humans actually prefer T5 XXL over CLIP. Okay, so that's that. Then this is followed. So text encoder basically takes the text caption and then passes it as input to the 64x64 the processed output from these encoders is passed as input to 64x64 image diffusion model. The image diffusion models essentially work like this. They essentially convert Gaussian noise into images from a learned data distribution by an iterative denoising process, right? So as you see, frame by frame, they are essentially going to start with the noise and then frame by frame remove the noise until it sort of gets into it starts looking like a very nice image. Okay. Of course, the model has to be influenced by the text caption, and therefore the model which step by step removes this noise is actually conditioned by text. Sampling or generation of these images sort of involves starting from pure noise and iteratively generating images that gradually improve in quality and decrease in the noise content. Okay. The way the training is done essentially is by using a bunch of data set of images where in fact you do the reverse process. So you essentially start with the data images and then you try to add noise such that finally you end up with Gaussian noise. And then on the way train a model which can predict denoised images or which can predict the error in some ways that has to be in the noise part component that has to be added while doing the process starting from dataset images to noisy images. Yeah. So in fact, while doing this diffusion process, there is another video which I had posted, by the way, about diffusion processes. But while doing diffusion process, a very popular technique to use is classifier-free guidance, which jointly learns which sort of jointly learns conceptually two models, but in general just a single model, right? So it sort of trains a single diffusion model on conditional and unconditional objectives via randomly dropping, this class label C, or in this particular case, caption C, during training, right? With 10% probability. So the idea is that you train a model epsilon theta, where theta are the parameters of the model, and epsilon is the name of is basically the model itself. You train the model epsilon such that first you condition on the caption C, but sometimes you also 10% of the times you actually drop the caption and therefore just condition on ZT, right? And that basically gives you a reweighted epsilon in that senses. So a reweighted epsilon, and that is what you use for diffusion purposes. Right? So here the weight, essentially, how many times you care, or rather how much do you care for the conditional model versus the unconditional model, is actually called W. Yeah, well, if you set W equal to 1, it is classifier-free guidance because, hey, you don't care about the classifier at all, right? But in fact, if you essentially have W greater than 1, then this improves the image text alignment. But in general, what it leads to is bad image fidelity and produces highly saturated or unnatural images. Okay. Now, this happens because of the train test mismatch. In fact, if you look at the training data, normalized training data is between -1 to 1. However, at test time, when you use W greater than 1, you cannot really control data to be between -1 to 1 only. It causes these X predictions, the image predictions, which are created in the process to exceed these bounds, right? And this mismatch is what causes heavily saturated or unnatural images. So one way is to basically do static thresholding, or rather basically do some sort of thresholding. So there are two ways to threshold the images that are generated by when you have W greater than 1. Having W greater than 1 typically is a good idea because, of course, it improves the image text alignment. But how do you handle the saturation part? Well, you could do static thresholding or you could do dynamic thresholding. Static thresholding basically means element-wise, you clip those X predictions, the predictions for the images, to -1 to 1. Okay, so that's basically of course, a sort of an obvious approach to do if your images are getting greater than beyond -1 to 1. Well, clip them. Okay, clip those pixel values. Okay. However, what they found is dynamic thresholding works better. So what is dynamic thresholding? Well, consider a certain percentile, let's say 95th percentile, right? And set S to a certain percentile absolute pixel value in image at time t. So at time t, you have a particular image, and you basically check for all values in this particular image, which are greater than 95th percentile. Okay, and let's call that value as S. If that value S is greater than 1, if it is less than 1, well, you don't need to threshold anyway, right? It all is good anyway. So, but if the value is S is greater than 1, then we threshold each value to the range -S to S and then divide by S, in general, making sure that everything is between -1 to 1. Okay. So what dynamic thresholding does is that it pushes saturated pixels, those near -1 and 1, inwards, okay, thereby actively sort of preventing pixels from saturation at each step. At each step, you sort of avoid saturation, but you don't really clip them, so that's not unnatural. You basically try to reduce them in some ways, sort of trying to do a normalization so as to push those values that are closer to -1 or closer to 1 to within the range. Okay. So the 64x64 image diffusion model, which basically follows the classifier-free guidance with 10% dropping probability and also dynamic thresholding, has 2 billion parameters. The original architecture is efficient unit model. Well, it's a unit model, but then they made it more efficient by doing a few tricks, right? It's of course conditioned on text embeddings via pooled embedding vector, which is added to the diffusion timestep embedding. So every time in this diffusion model, you're going to have timestep embeddings anyway, but you also add the pooled embedding vector corresponding to the text embeddings of the caption coming from your T5XXL model, right? We further condition on the entire sequence of text embeddings. Text embeddings typically are used in diffusion models in two parts, right? One is basically for added as part of, with the diffusion timestep embedding, and the other is that influences the attention which is computed for the attention layer. So you further condition on the entire sequence of text embeddings by adding cross attention over the text embeddings at multiple resolutions. So at multiple resolutions, you have those attention layers and you add them. Okay. After the diffusion is done, so of course, the pipeline is as follows. You start with the frozen text encoder. You do a text to image diffusion model. You have a 64x64 image, but here you want to increase the resolution from 64 to 64 to 64x64 to 256, and then 1024 to 1024 cross 1024. Okay, and you do that using super resolution diffusion models. So two of them. Basically, two of those models chained one after the other so as to increase the resolution of the image, which is generated. A low resolution image, which is generated by our text to image diffusion model. These two models in turn have 600 million and 400 million parameters between them. So therefore, totally overall Imagen model, is 3 billion parameters. Right. Of course, beyond the frozen text encoder, which also is quite large in that senses. Okay. Of course, while training these super resolution models, you want them to be robust, and therefore you add noise. So the output that is generated by text to image diffusion model, you add noise to that, Gaussian noise or blur, so as to make sure that these super resolution models are robust in nature. Okay. So how does Imagen perform? Is it better than DALL-E? Is it worse than DALL-E or DALL-E 2 and so on, right? So, well, here are MS COCO results. So MS COCO results, and again, zero shot results on the 30K set in terms of FID scores. And what you observe is that Imagen established a new state of the art, right? basically, again, late 2022 or mid 2022, well, this happened. Well, we have another model which is actually better than DALI 2 in terms of the FID scores. Remember, lower scores are better. So in terms of FID score, yes, it performs better than DALI 2 on MS COCO data. Well, they also got human judgments done with respect to the actual image. So they took a caption, there was an actual image also, right, associated with the caption. Well, they passed the caption to Imagen and then figured and then generated generated an image from Imagen and then got labeled by human annotators in terms of photorealism as well as image text alignment or caption similarity. Okay. So they did it for two different sets. If you look at all the images, then they observed that in terms of photorealism, well, Imagen is less photorealistic as compared to the actual data. But remember, we are comparing with actual data, which is Oracle, and not really with some other model. Okay. But then in terms of caption similarity, well, it was performing almost as good. If you observe these two values, it's performing almost as good with the original images. Well, human annotators funnily also found sometimes that the caption does not go with the ground truth images. Sometimes it happens thanks to the noise in the data anyway. Okay. Now, if you remove those images which relate with people, right, for example, images labeled as man, woman, men, women, person, people, child, adult, and so on, right, boys, girls, and so on. In that case, we find that, hey, in general, the photorealism scores improve, but then, caption similarity remains the same. Okay. So that's that. So basically saying that Imagen performs reasonably well, even when compared with the ground truth images. Okay. Compared to DALI, right? Now, Imagen is way better in terms of many perspectives, right? So here are DALI results, DALI 2 results, right? In fact, and here are Imagen results. Okay. And here are the prompts which were used to generate these results. Okay. The first prompt is a black apple and a green backpack. So you see, DALI 2 got this wrong, right? So it's not a black apple, but Imagen actually got it right. So it's a black apple and a green backpack. Yeah. Another one is more of compositionality and sort of odd cases which don't typically occur. So a panda making latte art. Okay. Now, if you see, it's not a panda making a latte art. A panda is being made in the latte art, right? But if you look at Imagen, well, the results are really good. They are reasonably good results where a panda is being shown to make latte art. Okay. Another one is the New York skyline with "Hello World" written with fireworks in the sky. So, DALI 2 folks also mentioned in the original paper that yes, DALI 2 is not that great at retaining spellings and does make a lot of spelling mistakes, right? While Imagen is actually good at capturing these spellings nicely and therefore comes up with reasonably good output. Okay. Now, what happens when you vary various configuration settings in Imagen? So for example, you can change the encoder size. You could use T5 small, T5 large, T5 XL, T5 XXL. So as you observe in this plot is also called as the Pareto chart. So if you look at FID score versus the clip score. So FID score is a distance score, lower the better. Clip score is essentially, it measures image text alignment. So essentially the higher the better in that sense. Okay. So what you observe is that as you change from T5 small to T5 large to T5 XL and to T5 XXL, you actually see that the results get better and better. Remember, lower FID and higher clip score are better. Okay. So, and here the plot is actually drawn by sweeping over guidance values from 1 to 10. Remember the value W there. So you basically sweep from 1 to 10, and then you plot this chart. Okay. Another thing that you could do, change in the configuration setting for Imagen is to change the unit size. Okay. So the unit size you can change from 300 million parameters to 500 million, 1 billion, 2 billion, and so on. And what you observe is that, of course, as you observe, with larger encoder size, typically you get better results. However, not as better, the improvement is not as good as the improvement you get when you increase the text encoder size. So scaling text encoder size is extremely effective. Scaling text encoder size is in fact more important than scaling unit size, because with unit sizes, there is not too much of sensitivity there. Yeah. Typically, what is also observed, you could also change the thresholding. Remember the thresholding on the image pixel values? Well, you could do static thresholding or dynamic thresholding, and it was observed that dynamic thresholding is critical. It is actually better than just doing static thresholding. And lastly, human raters actually prefer T5 XXL text encoder compared to clip on Drawbench. So now this leads to the question, what is Drawbench? Okay. So what is Drawbench? Drawbench is a challenging set of prompts for text-to-image model evaluation. Okay, so you want to evaluate how good these text-to-image models are? Well, Drawbench actually has a set of prompts using which you could ask the model to come up with images, and those images will then need to be manually annotated. Okay, these prompts belong to 11 different categories, as you see them here. They test the ability to faithfully render different colors, specific colors, to also generate numbers of objects. They are also, there are also prompts which capture spatial relations, text in a scene, unusual interactions between objects, and so on. Okay. In fact, these categories also include complex prompts, long, intricate text descriptions, rare words, misspelled prompts, and so on. Okay, here are some examples as well for you to sort of look at what do these all mean. You see misspellings, and then hey, does the model create a good image or not? Right, conflicting a panda making latte art. Right, is the model good in terms of creating images for such conflicting kind of scenarios or not? Okay. And what you observe here is that, if you compare Imagen with respect to any of those popular models for text-to-image creation, DALL-E 2, Glide, VQGAN plus Clip, or Latent Diffusion, you sort of observe that Imagen is hands down better in terms of both alignment as well as fidelity as rated by human annotators. Okay. Now, the Imagen model has been extended further by these folks so as to create something called as Imagen Editor and Imagen Video. Okay. So what is Imagen Editor? Well, Imagen Editor is essentially, let's basically look at this video to understand Imagen Editor. It's basically inpainting, right? So essentially, the user highlights a small part of the original image and then gives a text caption to highlight how the image should be changed, and well, the image is changed accordingly. Okay, inpainting is done accordingly. Similarly, similarly in the lower scenario, you basically give in-painted image, a very small part, and then you give different text captions, and accordingly you see the images are being generated so as to match with the caption. Okay. So this involves how does this work? Well, it involves a cascaded diffusion model, which is built by fine-tuning Imagen on text-guided image inpainting. Right, very much in lines with the way inpainting was, very much in lines with the way DALL-E 2 was trained for image inpainting. Okay. But there is a slight difference here. They use object detectors to actually propose inpainting mask during training. In DALL-E 2, random crops were actually removed so as to generate training data for image inpainting. Right. So while coming up with Image Editor, they also sort of contribute Edit Bench, which is it evaluates text-guided image inpainting edits on natural and generated images, exploring objects, attributes, and scenes. That's basically a benchmark data. Okay. And at least the paper says, Imagen Editor paper says, well, they are better than DALL-E 2 and Stable Diffusion both, which is great. Okay. The other way that they have expanded this work is to basically propose something called as Imagen Video. So as you see, now people are also into the realm of generating videos which are text conditional. So you give a text prompt and then generate videos. Text conditional video generation system, which is based on a cascade of video diffusion models now, okay, rather than image diffusion models. Given a text prompt, it in fact generates high fidelity videos using a base video generation model and a sequence of interleaved spatial and temporal video super resolution models. Okay, so of course, everything that is now image specific becomes video specific in this image and video framework. But the great news is that yes, you can actually take text prompts and generate the short videos out of them, short video clips. Okay, so that's that. In summary, Imagen is a text-to-image diffusion model. It's a model which takes text prompts and generates high-quality images. These images have better photorealism and text-image alignment compared to DALL-E 2. It's a 3 billion parameter model, along with, of course, another text encoder with diffusion, with a diffusion model, unit-based diffusion model, and 2 upsampler models, super resolution upsampler models. In this paper, they also contribute Drawbench, which is a benchmark set of prompts for text-to-image model evaluation. And well, there are 2 other follow papers in terms of Imagen Editor and Imagen Videos. Imagen Editor allowing for inpainting in the images, and Imagen Videos, which helps you create short video clips given text prompts. You can experiment or read more about Imagen at imagen.research.google. Thank you for watching. Hope you liked the video. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.